Welcome to another game development video experiment for the game development course at Full Sail University. Today we're going to be talking about the Unity's animation system, and we're eventually also going to be talking about 3D character controllers and how we can move our character around in a 3D space as opposed to 2D, which we've already done. So this is the finished product that we're looking for this particular video. As you can see here, we've got a character, and the character looks like he's walking, although he's actually not. You can tell very easily if you look at the scene view. Let's bring the scene view over here. The character is just walking around in place, so there's no movement, there's no actual behavior being applied. We're just transitioning from the idle animation to the walking animations based on input. And I'm going to show you how that's done. I am going to be showing you from scratch. This is a blended tree of animation states, which you can see here, and I'll walk through all of these things in detail. So without further ado, let's go ahead and start a brand new project. Okay, so we have our brand new project. It's empty. All we've got is a main camera. Otherwise, there's not a lot going on. So let's go ahead and get started. The first thing that we're going to want to do is organize our assets folder appropriately. Dumping everything directly here into the assets folder seems like it's probably bad for organization. I like to be organized with my projects, so let's create a art folder because we're going to import a bunch of art. Now inside of here I want you to create a new folder and create a folder named actor. Inside of that folder, you are going to drag in all of the different animation files that you have available to you that you downloaded from the assignment. Okay, here I have the different animation files. You may not have as many animations as I do because I've probably restricted some of them from you. But grab everything that's inside of the character folder in your package and just drag all of that into the actor folder that you've created in your assets directory. Then let Unity do the heavy lifting of importing all the different resources. Perfect. Next, we need to talk a little bit about the importer, which is what is showing over here in the inspector. This is all of the options that you can tweak depending on how you want Unity to treat this art asset that you've given to it. Now, one of the things that Unity's done automatically that we want to undo is it's created an avatar object for every single one of these animations. This is unnecessary for us. We want to use one avatar definition. We're going to use the bind avatar as our one avatar definition, and then all of the other animations should copy from the bind avatar object. So what we're going to do is for this particular series, we're only going to use the walk animations and the idle animations. So I want to change those and fix those. So first things first, let's go to the bind pose, and in the importer, click on rig, change the animation type to humanoid, and hit apply. That's all that you need to do for the bind pose. So we can go ahead and collapse that. For the idle animation, for the avatar definition, instead of create from this model, we want to copy from another avatar. Nothing's happened quite yet. All it's given us is this source member variable, and we're going to populate that with the bind avatar. And it's going to ask us, because remember we changed the bind avatar to a humanoid animation type, it's going to ask us if moving to the bind avatar is going to make this a humanoid avatar as well, and it's asking if that's okay. Yes, it totally is. We do want to treat all of our animations as humanoid rigs. So we go ahead and hit apply here. Um, this error comes up for me because I'm storing all my project files on Dropbox. So if you're doing something similar, then you might see something like this whenever it's trying to modify those files on Dropbox. Don't worry about it. Just hit try again, and it'll eventually work. If you're doing this just on your local PC, like on your local disk space, that message should not appear. Don't worry about it. Okay, so this is now applied. However, we still need to make some changes to the animation. If you notice, for FS dummy idle, we have this file here called take001. That take001 is actually the animation. You can see it's barely moving. You'll be able to see it better on one of the other ones. The problem is that take001 is not a very descriptive name for this animation, especially when you look at every single animation that we have. The animation name itself is take001, which is going to just make it a lot harder to work with when every animation has the same name. So we just want to fix that by clicking on the idle object, and then here on the animations tab, you can see all the different clips that are associated with this object. There's only one clip at the moment, and that clip is take001. We want to rename that to idle. Additionally, idle is an animation that's supposed to loop forever, so go ahead and click the loop time checkbox here to make sure that it is a looping animation. Hit apply. Okay, and you'll notice that the avatar definition has actually disappeared from idle. Right, here it is for one of the other states. Here's that avatar definition that's being created here. Remember, we changed the import settings for this. Instead of creating an avatar from this animation, we're using the bind avatar. So now this is set up, we're going to need to do the exact same thing for all the different walk animations. So let's expand all of those. And once we do it for these, then the rest of them we can ignore them for now. If you're ever going to use them, then you'll need to do the exact same process. Switching over to rig for walk backwards, we want to copy the avatar definition from another avatar, and we want to copy the bind avatar. We would like to make this a humanoid. On the animations tab, change take001 to walk backwards, and make sure that this is a looping animation. I did change that file name, right? Yeah. Alright, so for walk forwards, we're going to change the name of this to walk forwards. Loop. Apply. Even if you have more things to do, like if you wanted to switch over to the rig tab, you still have to hit apply first. You have to apply any changes for any of the tabs before you move on to another tab. So for the avatar definition, we want to copy from bind avatar. Alright, walk forward is done. Let's do walk left. Copy from another avatar, and we want to copy from the bind avatar. Apply. Switch to the animations tab. This is the walk left animation. So we're going to change the name of it to walk left so that it's easy to understand. We're going to make sure that it's a looping animation, and we're going to hit apply. Finally, walk right. It's a bit tedious, but it's going to be worth it in the end. Especially since you have to do it for each and every single one individually. Alright, perfect. That's done. Next step is to go ahead and create our character. So go ahead and drag the bind object directly into the scene. Go ahead and position the camera in such a manner that it has a very good view of the character. You may want to go ahead and add a directional light into the scene so that we can clearly see our subject. So let's go ahead and do that. And let's move that out of the way. It doesn't really matter where it is. It just matters that it exists. And let's turn our character around so we can see him looking at us. And there we go. If we hit play now, you'll see nothing happens. Not very exciting. So let's go ahead and make some changes here. First thing that I want to change is the name of this object from m_fsdummy_bind. We want to just change this to actor. Then, in your assets directory, I want you to create a new folder for prefabs, and I want you to drag the actor into the prefabs folder. And now we've got a prefab for this. You'll notice that when I select on actor, now we've got the apply button in the inspector. As we're making changes, then we want to make sure that we are applying things back to the prefab so that in other scenes or other levels, all the changes that we make here are applied to the actors in other levels as well. One important thing to look at is now that we've dragged this model into the scene, you'll notice that the inspector already has with it this component called an animator. I didn't have to add this myself, it just came already attached. The animator is what's going to be used to manage all the animation transitions. So going from the idle animation to the walk animations, we're going to use this animator component to help us do that. This apply root motion is an interesting one because some animators like to include movement inside of the animation. So for example, if it's a jump animation, they will animate the character actually leaving the ground, as opposed to other animations that with the jump animation, he'll do the jump animation, but it'll all be on the ground. What this means is that if you want the movement in the animation to be applied in the actual game, then you need to leave this checked on, apply root motion. But if you are going to be developing the behavior and the animations are all just in place, then you want to uncheck this, which we are going to do because we are going to be managing the behavior of the object, not the animations. So go ahead and hit apply. Okay, the last thing, these two guys over here, we can not worry about these. We can leave these as the defaults. But this one right here is very important, and that's the controller for this animator component. This is an asset that we have to create, so let's go ahead and do that now. Let's go to the assets directory and create a new folder, and this folder is going to be called controller. Inside of the controller folder, right click, go to create, and go to animator controller. And we're going to call this actor. Going back to our actor, now for this controller variable, we can drag the actor controller and drop it right in here and hit apply. If you double click the actor controller, a new window will be available to you. This is called the animator window. Let's see if we can get some more space. Instead is we're going to create a set of blended animations depending on input. So we're going to create a new blend tree. Let's go ahead and click that, and then rename this object from blend tree to Now, if you double click on locomotion, because it is a blend tree, it will take you to another layer of the editor. Up here is where you're going to find how to traverse throughout the different layers. So you can click on base layer to get back to the base layer. You can double click on locomotion again to get back to the blend tree. This is the blend tree root node. I'm also going to rename this to locomotion. So the locomotion root node by itself, it does nothing. Over here, these motion parameters is what's going to determine what this root node is going to be blending between. This parameter here, which is empty and does not have any options, is the parameter that we're going to use to determine which animation to play. Parameters can be added here by clicking on the plus button and selecting the parameter type. Blending animations only works with floats, so we're going to add a float called speed. And now, if you look at the parameter up here, you'll see that now that we have a parameter added, by default, speed is added here. There's just one problem. In order to tell if I'm walking left or right, I need to know more than just speed. I also need to know direction. So let's go ahead and add one more float, and we're going to call this float direction. Okay. So now we reach our next conundrum. Our blend tree only has one parameter to work off of. So I can either blend based off of direction or I can blend based off of speed. I want to actually blend off of both. So we're going to change this blend type here from one-dimensional blend to a 2D simple directional blend. Once you do that, you'll notice that two parameters have appeared. We want the first parameter to be direction, and we want the second parameter to be speed. You may need to, in order to get this to update correctly, you may need to change the value and then pick speed one more time in order to get this to update correctly. So just be aware of that. Okay, so now that we've got our parameters set up, let's go ahead and add our motion fields. It's important to note that if you're working on more complex mecAnim visual state machine trees, you can actually nest blend trees together, and there's several examples on the internet of how you can do this. We do not need this, so we're just going to add motion fields. We're going to add 5 motion fields, so we're going to be blending between 5 different animations based on the values of speed and direction. Okay, before we talk about this, let's go ahead and just hook up all the different animations. Now we want to do this in order. Notice how when you go to input one of the animations by clicking on this dot here, you see all these take 0 ones. Thankfully, we went through the effort of naming the animations we're going to use, but you can see here that if we hadn't, trying to figure out which take 01 was idle and which take 01 was walk forwards would have been a cumbersome and tedious task. So highly recommended that you actually go through the effort of renaming those animations. So let's grab walk left, and then let's grab walk forwards, walk right, walk backwards, and finally idle. Okay, so now that we have all our animations hooked up, and you can see in the animator window that this root node, this locomotion root node, is going to use direction and speed to determine which of these animations it should play, or perhaps a blend of the animations. The problem is you have to tell the engine how to interpret the thresholds and how to blend between the different animations. Right now, it's a bit of nonsense with these blue dots and red dot not meaning a whole lot of anything. Notice that I can move this red dot around, and when I move the red dot around, these slider variables get updated. So this is just a way for you to test the values of direction and speed and see which of the animations are going to be the active ones. The problem is none of these thresholds are correct for what we actually want to use them for. So let's modify those here. This posx variable is actually referencing this direction variable. So on direction is either going to be -1 if we're trying to move left, 0 if we're in idle, or +1 if we're trying to move right. So we're going to make this -1 for posx, and you can see the map is already starting to change. For walk forwards, we're going to skip that one for now. For walk right, we want this to be +1. Remember, the x is for direction, so -1 is left, +1 is right, and 0 indicates that we're not trying to move in a direction. So this should be 0 here, and this should be 0 here. So the only time that we're trying to change our direction is when we're walking left or walking right. Everything else is at 0. For the pos y, this is about speed. Now speed is positive when we're trying to run forwards, and it's negative when we're trying to run backwards. So we've got a similar situation here. And when you have everything completed, everything should be, walk left should be -1, 0, walk forward should be 0, 1, walk right should be 1, 0, walk backward should be 0, -1, and idle should be 0, 0. So this blue dot here refers to idle. This is walk forwards, this is walk left, walk backwards, and walk right. And this is the value of direction and speed. So you'll notice that when this red dot is directly in the middle, this circle around the idle indicates that this is the active state. If I start dragging this up, you'll start seeing that the circle is starting to blend between the walk forwards animation and the idle animation. And the closer I get, the more control is handed over to the walk forwards animation. If I transition this over to the top left over here, we'll notice that we have large circles around the walk forwards animation and the walk left animation. What it means is that it's going to blend these two animations together to get the correct animation that we want, and this creates a very smooth character-driven motor. Okay, so now that we've got all of that set up, I'm pretty sure that we can go ahead and just save. Oh, I have not named this scene yet. Let's see here. Let's create a new folder called Scenes. And I'm going to call this Experiment 5 mecAnim. Save your scene, hit play. And there you go. Notice that we're no longer in the bind pose. We're in the idle animation, which is nice to see. Unfortunately, by trying to move the character around, none of the animation transitions seem to be working, which is a little bit weird. So let's take a look and figure out what we can do to make that happen. I guess the main problem is that the speed and direction variables that we added in the animation controller, they're not actually changing. We need to modify these values in order to have the blend tree actually behave correctly. So we're going to need to do that from script. So on the actor, let's go ahead and add a new script component. We're going to call this the actor state machine. Later on, we'll go back and add the data model. Hit apply. Let's go ahead and add a new folder for scripts. And let's drag the script inside of there. There we go. So here's our actor state machine. Let's go ahead and move these curly braces onto the next lines. I prefer having my curly braces on the same line together instead of one being up here. It costs a line to do it, but I like the organization. So in order to modify those parameters from script, we're going to need to actually store a reference to the animator component variable. So let's just call that anim for now. And in the start function, we want to initialize that by setting anim equal to getComponent animator. And just because I'm a little paranoid, I want to make sure that that actually was successful. So I'm going to check to see if the result of that is equal to null. If the result of that is equal to null, then something went wrong. So this is actor state machine start function could not retrieve the animator component. And that way, if anything ever happens where this anim somehow stops working correctly, this will let me know in the debug window that something bad happened. So it's a bit of future proofing. Otherwise, I'm just going to assume that it exists and that everything's working fine. So using that anim variable, we have access to a few different functions. Set float, anim dot, no, not animation, anim dot set trigger, and anim dot set integer. So we have these four functions that will allow us to change the values that are stored inside of here. Notice how they correspond with the four different variable types that you can add in the animator controller. We added two floats, so we're going to use the setFloat method. Let's see here. Now, when you're setting floats, the first parameter is a string parameter to match the name of the variable that is inside the animator controller. So our two variables are known as speed and direction. We're going to be modifying these both, which means that we're going to need two calls to anim.setFloat. So speed and direction. The second parameter is the new value that you would like to provide. We have not calculated that yet, so let's go ahead and do that now. I apologize if you're hearing some lawnmower noises in the background. Hopefully it's not too bad. So we're going to grab the input for both the vertical and horizontal axes. And for the speed and direction, we're going to use these two values to put in there. So speed is going to be the vertical axis, and it's going to go from 1 to -1. And the same story with the direction. The direction that we're going to use H for the horizontal, and that's going to go from -1 to 1 as well. So if we save this and go back to Unity and press play, we notice that we are pretty much back at where we were at the very beginning of this video when I was showing you the final result. So while we're walking forwards, if we want to walk left, it blends between those two animations. If I let go forward, it goes further left. If I hit forward again, we go to the diagonal. If I let go of left, walks back forward again. And we also have the blending moving backwards as well. So there's blending backwards and left, blending backwards and right. And there we go. That is your introduction into the mecAnim animation system. You can see that while this is running, the locomotion state is the one that is currently active, so that's the one that's kind of going back and forth between. Moving forward, we're going to work on implementing the behavior of this object. As you can see, the object doesn't really actually move anywhere, it just moves in place. So we're going to be changing that so that we can actually move the character around, and then we'll add some other animations as well, so that you can get an idea of what we're looking at. So thanks for watching. I hope you were able to get your character at the same position as mine and ready for the next video.